I forgot, otherwise all notifications gonna be wrong. But we're back to this game 12 thing, I think, today. Haskell game dev. The plunder game. Okay, sure. We're not, yeah, I've kind of decided to just trash this entire idea of summoning cities. We spent 3 hours on it or something, and I'm just like, you know, maybe we should call it a day here. Why am I here? This project. I'm in the wrong project. I should be here. And I should also make a streamer account so I don't mix up projects like this. It's kind of dumb. But yeah, things to do, right? Yeah, so I'm gonna, well, there is one more thing I want to explore actually before trashing this entire summoning cities branch. And it's this basically. We can put a function in here and then we probably can make it work. But what I wanted to do specifically is see what the template Haskell generates in here. So, I mean, how does this even work, right? This is just becoming a abstract syntax tree, which then is modified by the singleton's function to produce a new abstract syntax tree. And you may wonder, what is an abstract syntax tree? Well, your document describes a abstract syntax tree. This is the abstract syntax tree. And we can pretend that we can run code on this tree. That's what templating code does, modifies the tree. That's what this also does. So my idea was that this would generate a type family. But I'm not sure about this. I think it does something else, because the way we represented it before, it was as a type family, and we couldn't get it to work. So maybe it does something else, or maybe I just don't know how it works. Anyway, we're gonna quickly look into that. But not too much. I'm gonna trash the idea, and we're just gonna continue developing the game normally without type level programming, because it just takes too much time for me. Yeah, okay, cool. Notification worked. Great. Oh, the mic is hearing that. Actually, I should reduce the gain a little bit, like this, because when I was listening to it last time, it's a bit too much. So this should be better. Like the gain, I think it makes it more echoey. Okay. I don't know why I don't have. How do I make this face? I don't know. Oh, I cleaned maybe or something. Who knows? I should add a disk indicator to my polybar thing. Yeah, I got a new bar and problems occurred because of that. On this machine it's pretty great, but I also ported the polybar thing to the laptop and it doesn't quite work for that resolution on the laptop. So yeah, I lost my disk space indicator as well because I don't know how to set it up. Yeah. Fortunately, Skybro gave a lot of examples, so it made it quite easier to do. Okay. So yeah, what I put in here is the dedump splices option in GHC, which will dump the splices. And what is a splice, you say? Well, a splice, I don't know how to. A splice is like well, that basically. It's the generated abstract syntax tree. So this allows us to inspect what template Haskell is doing. And in this case, I want to know what type family is occurring. But it looks the same, right? It looks the same, Bija. But then you get this as well as Bija. What is even a singleton? Maybe if you have a singleton, you can do this. But this is so strange to me. Because now you're doing the pattern matching twice. You're doing it at type level and at value level, I think, is what it looks like to me. So what are you even gaining by doing this stuff, right? You get the instance for Bija. What? You get a sing I instance. Hello Skybro, how are you doing, man? Welcome back to this summoning this branch, which we're gonna can, by the way. I thought long and hard about it, and this is just not worth my time to figure this out. I don't care enough. And you know, Some people might think this is interesting, but it's not interesting to me. It's just wait, like, okay, look at this. Look at this code it's generating for us, right? This is the same function as we have here, except this is at a singletons version. And here, well, what they're doing is at type level, they are creating this function, type family. And I was like, okay, you have it at type level, right? You're done. But what they are doing now is also at value level. Exactly the same function. Exactly the same function. Why would you do this? This is just a waste of time. You got hexagons. Yeah, we should just scan this summonings of this stuff. It's stupid. It's wasting time. Why? I don't get it. I'm so confused. I'm like, okay, so I started being quite confused. No, I thought I knew what it was doing, but now I've looked into it. I'm like, I don't have a clue what type level programming is. Well, I know what type level programming does, but I don't know what this single stuff is doing because it's not working for me at all. And I think, you know, I do the good old Haskell strategy of just not looking into it right now and abandoning it because this is not working for me, okay? You got hexagons. I will make one without hexagons. Oh, Joe Castrian, thanks for following. Oh, you're from the Discord, right? From the functional programming Discord. I don't know if he's still watching, but yeah. We're gonna can the summonings at this branch, and we're not gonna look at it again for a long time because you know, this is not ergonomic either. If you have a bug at the type family level, you know what will happen? It will just give you the code, and it will just stop there, and there's no progress. And I'm like, okay, hell, welcome. Like, I was thinking about it. We got these bugs in the code, and the way I was debugging it was just like commenting out parts of the code, and that's how we would find if something was working or not. So it's like, you know, okay, maybe you can make things faster with type level programming, but it's just so painful to do. I don't know why anyone would do this in Haskell. And I have a lot of respect for Goldsphere, like trying to make this more ergonomic, but I don't know really why. Goldsphere, right? He's the guy doing. I think that's his nickname actually, but he's the guy pushing type level programming and dependent type programming in Haskell, and you know, he's making like constantly debating about it. But we're gonna abandon it because I feel doing game development is more fun than, you know, we can make a commit for this, like add splices to see what the th is doing. Okay, so if you would accept th, like you would write your functions like this, you know, it will work. You could have your type level thing functioning. But to me, like, yeah, you're right, it's working like this, but now I introduced both template Haskell and it desugars it. It's still in a type family and a value level function. I'm like, why would I do this? This is just, what is the advantage? I don't see it. Maybe someone can explain it to me. I mean, I feel I should, like, the amount of frustration I get from looking at this, I feel I should write about it and just like ask people, you know, because I feel I should do that. You know, this is maybe my next blog subject, to write about singletons and just my utter confusion. Yeah, I think that's a good idea, as long as there will be plunder. There will be plunder, Skybro. Don't you worry. Don't you worry. Now we have a bit of a problem because I don't know where we came from. Can I look at the log? We came from Combat 2 3 weeks ago. So all this stuff will be abandoned. And we're gonna go back to Combat 2 and we're just gonna ignore the existence of singletons entirely. So, you know, this is the current version. I just pushed it to origin. This was all trying to make the singletons work, and you can just basically watch my struggles online if you want to, or watch the previous VOD. I don't know if it's still online, but yeah. And we're gonna go back here and we'll move from there. 5 more singletons. Yeah, it's like, you know, we spent 3 hours looking at singletons and trying to make it work and being stuck at type. And I like, you know, I started being like really exciting, stuff worked. It went up, like, oh, it's so cool, look at this, it's all working. I was so excited explaining it. You know, this is the, I don't know if you can call it theory, but like this is the what's happening. And then, you know, we had to make it work, like the final step to make it all work together. We couldn't figure that out, and I was just like slowly falling into a depression while working on that. So yeah, if you like to watch a slow descent into madness, you should definitely check out that VOD that's no longer existing. I think like Chiroptical, for example, stepped by at the last moment, and he was like, "Hey, Uppy, how are you doing?" And I'm like, "Chiroptical, man, I'm slowly dying here." I'm sorry, man. You know, being self-aware of it. I don't know why we're building stuff. Oh, we probably upgraded as well to deal with singletons. And yeah, we maybe need to re-enter. Did I re-enter the show? Looks like it. I don't forgot what I did 2 seconds ago. I must have been talking while doing stuff. It's a bad habit of mine. You know, things become so habitual that you can just talk over it while doing programming. Like, this is how it looked before, by the way. It was just like a couple of lines of code. We can simplify it a little bit, though. We thought of a way of simplifying it through singletons research, I guess. No, this is perfect, actually. So what we did before is we split it up into a separate data type for the damage. So you got like super effective, ineffective, and no damage. And then like that, you could split up this function and make it a bit more simple. But you know, like this big lookup table is simple enough according to me. So yeah, deal with it. And then the other thing you could do is instead of using an int, you can maybe like make a health new type. Health, or you know, you can make it even like a data health, and you say like 1 health, and then 2 health. Like that. But, and then you just like, you know, you pin them all out like this. And the advantage of doing this is that you cannot go bigger than your bounds. So rather than having, you know, the size of integer, you have the size of whatever health is. That's something I thought about. It's too much work. Although you get like more type safety, technically, you get more type safety. But the other thing you could do is instead of using an integer, you can use word. Let's go word, data word. I prefer smart constructors in that case. Yeah, that's another strategy to use, I guess. But there's this other type, and this will be an 8-bit type. So how big is an 8-bit type? Well, and this is just ones and zeros. This is not even not really a number anymore either. And they're unsigned, so you cannot have negatives. Which makes sense for health. You know, you cannot have negative health probably. This will go up to 256. So maybe this type would fit better than an integer. Because you cannot go negative, and it's only 265. So you like, you know, we probably won't want to make it up to 10, but 256 is better than however big int. I think int is 2 to 32. Oh yeah, that's an int. Actually, it's half of this because it's signed, so you only get this far. You have to have 1 bit for signing, which is 1 doubling of values. I can use this. What's the point of... No, we're gonna be 0.3, man. Maybe you have ambitions of adding points to your code, but no, my game dev will be 0.3. It's a shitty joke. Yeah. But if you want to have a serious answer, it's just for fun. That's the point. Why would you do anything in life except for fun, right? It's, the Taoism way of life, you know? Go with the flow. I mean, you could drive this even further. Like, what's the point of doing any game dev at all? There's no practical use to game dev, except because, you know, there's no practical use to gaming, except that people want to game. Why do they want to game? It's just wasting their time, right? Like, to do something productive. Well, people choose to. I don't know. Yeah. You could go really far like that, but you could also say, like, you know, it's fun. That's why. Why do you think something is fun or interesting? I don't know. That's just how people are. But like, okay, you could have fun developing in Java as well. It's a different kind of fun though. Like you could experience fun by getting something done. Like I think Cryptical got a lot of stuff done, and struggling with I think the last time we did the type level stuff with singletons, it was a lot of fun, but we didn't get anything done. But it was like a lot of fun to experience that kind of pain because, you know, it makes you realize why are you doing something a certain way, I guess. Like you're learning, you know, that's another kind of fun. Learning is usually not very productive. Honestly, it has been fine. Mustache has been a very weirder. I don't know what. Oh, that's a template language, right? Yeah, you know, and learning things in Java is probably more useful as well than Mustache because, you know, the likelihood of encountering Mustache ever again is kind of small compared to Java. You know, you would, if you want to do Android, for example, you also have to use Java. So I would say it's more productive to learn Java than Mustache. But then again, maybe you think Mustache is more fun. I don't know. I think you were kind of forced into it though, so suddenly leaves the SP3. That would be amazing. It's gonna be a hardcore C++er. I mean, it's kind of how you pitch your like personality on Twitch. I think both Chiroptical and I kind of deeply embedded into functional programming. But you could also decide to change that, right? Like, oh, this is a general programmer. Been there all along. Apologizes for a joke. I mean, it's kind of strange, object-oriented programming, because like the impression I get like looking at it from, you know, having to do that, and it, like in university I remember it making sense when I was doing it, object-oriented programming, because it just felt like you're just adding labels to things and you have to use a noun. It made so much sense, right? Like, okay, that's a nice way of splitting up things, I guess. And then you learn about, you know, functional programming style and like something like the map function, those higher order functions, those combinators. Like, oh wow, this is really cool. But you know, you still do the object-oriented stuff on the side. But for me, yeah, I don't know where I'm going with this actually. Uncle Bob. Who's Uncle Bob anyway? I don't know him. So we are rebuilding all this stuff because I think we changed the version of Nix while being on that branch. Now we can check that out actually, I guess. We can check our disaster unfold, and I think I've done a garbage collect on this machine. I must have. I'm trying to make windows out of this, but oh, there we go. Yeah, so my setup is like, okay, I'm looking at a small, I hate this picture. It's too happy. Freeman was right. It's so happy. I should change it. Right. So I want to make a comparison between you and you. So can I see it now? Yeah, we even mucked around with, you know, like any good stream, we mucked around with Nix, because that's what we do. Just like to muck around with Nix, I guess. Yeah, and then we kind of improved this code a little bit in that we split up the actually, I was thinking about it. This looks like the algebra-driven design book with get this, that, get damage, get because they use the same names. They use like get points or get. I should write a book review about it, by the way, because it's like really interesting. But there are some issues with it, I feel. Yeah. So this was our idea: get the damage out like this, which worked. This worked, which is cool, but this didn't work, I think. Yeah, we tried to get the singleton out, a type level here, and then this couldn't compile, which was annoying. And then the arbitrary stuff, right, whatever. But we did split it up with a damage. Maybe we should copy paste this, because I like this split up idea. And then we'll just like translate this code. If you aren't been yeah. What are you even doing in life if you're not messing with Nix? Oh, we're in the shell, by the way, so we can do stuff. I mean, I was talking to some people wait, this is respawn. Why am I should have a separate streamer account. Right. I was talking to some people that may have been of a larger company, and they were trying to hire Haskell engineers, and they were actually like surprised of that all the Haskellers started talking about Nix. And I was like, okay, I'll just explain why that is, I guess. Yeah, it's kind of funny. Word, you're not like, why is not in private, right? Everyone knows about Word. So that's the other part of it. We can make a beats function, which we can just copy paste. Beats. Beats, yeah. Because this setup is nice. That's endomorphism, by the way. Totally recognize it. And you got the beats function. Then you get this get weapon damage, which gets damage out. Wait, what? Oh right, this unifies beats and get damage. Maybe weapon. This is weapon to. Maybe this is like combat. And now we're just gonna translate this into a normal function. Like this. It's kind of, you know, there's a one-to-one mapping between functions, and that's what one previous stream was about. You know, oh, it's so easy to do this. It's not easy to do this. It's not. Don't be fooled. But this is the idea. Okay, we got the nothing branch. The other side is nothing. Oh, shouldn't that be large? Small effect. No, it should be large, man. If you're attacking someone without a weapon, you should have a large effect. You know, you got like this guy is the attacker. This guy is the defender. Defender's damage. Like that. Let me fix my formatting, because otherwise the viewers are gonna complain. Yep, he's not a true Nix believer. I forgot. It's true. I don't really believe in Nix as a religion. Not my god, man. It's not my god. Right. Just B. This is where you're gonna get beats. Beats A. So if A beats B, I mean, I guess multi-way if is best here. If A beats B, then it's large. If B beats A, it's small. Okay, and what's the other case? Otherwise, medium, and that's like, so otherwise, also known as true. There'll be medium damage. I know how to do multi-wave. Wave. I think I did that right. Yeah. And then finally, no effect. I don't know what no effect will be. I guess if you're attacking someone without a weapon, you won't have any effect. If you are attacking someone you have a weapon, the effect will be small. No, it should be large, I think. And then I think this is already finished like this, right? So in here well, let's just call it get damage. And then finally you just assign damage to whatever damage factor. So this function will become get damage applying defining Then we just pattern match on the damage. So you get no effect, you get small, medium, large. Case of no effect, 0. Small, medium, RNG, large, and that's your function. So we split off, we basically split off that pattern matching, making it a lot smaller, like this. I don't know if you can see it easily. Yeah, now the lookup table is a lot smaller because this is type signature. So we now have two small lookup tables, one here and one here, instead of one big one. And the advantage of doing this is we can add more weapon types, for example, and we just have to modify this part. Or we can have more damage types and we have to modify this part. So we split up the concerns. And it's a little bit better. It's like, it doesn't matter that much. This is the most sophisticated combat. Yeah, it's written in Haskell, man. It has to be. It has to be sophisticated. Yeah, I should also do something more constructive with the points, but you know, I don't really care too much about it. Ambiguous occurrence, large. Should I call it bigly instead? Sounds like a yes. Small. How to small? Dwarf. No, tiny. Tiny works. Tiny, medium. I know. Instead of small, we call small. Good match type. Damage to left, damage to right. Where's this? Beats. It's basically rock, paper, scissors. It is rock, paper, scissors. What? It's what I say here. It's rock, paper, scissors. Of course, rock, paper, scissors. That's like the entire. I even have comments. And it's not completely rock, paper, scissors because I misspelled scissors. Scissors. That's the most difficult word to spell. Damage to right. Damage. Combat. This is combat module, right? Yeah. So let's just jump to the line 91. Damage to the left. Apply damage. Oh. You know, let's give a type alias to the word. So rather than using word 8, we'll just call it health. Because I want to change this probably later. Wait. I'll just keep it in for now. Not deal with it. Because, you know, who cares about being correct? We're making a game after all. Rock, paper, polygon. Or hexagons. This game is about hexagons, by the way. Because hexagons are the best hexagons. Could match type weapon to bool with actual type weapon. What? Oh. I need to introduce equality. That worked. Okay, cool. So the joke is over. Let's commit this. This small refactor. Introducing damage step. Swing. Now let's apply damage and health and stuff like that. I have no idea how to do this. I think this worked. Yeah, this worked again. Okay, cool. So this is our game, right? Oh, did it crash? Yeah, it crashed. Can't actually play it like this. We need to run it from Kabul. I don't know why, but it doesn't matter because, you know, DHCI is not something that will be shipped. So we don't need to be worried about that. It's probably some bug in DHCI, who cares? Oh, this is the specification. Oh, we should test at some point. But for now, let's just run the game. Oh, what do you want to run? Or maybe X? This is Kabul saying to us it doesn't know what to run. It's using way too many words to like, instead of like, oh, I don't know if I should run exa or unit. Please specify. No.
The run command is for running a single executable at once. The target reverse to nothing, by the way. Jesus Christ! They want to write a book. Okay. Oh look, by the way, they have weapons. These guys have weapons. You can see it. We zoom in. We fixed the... don't I have like boomer? I think my boomer broke. Well, they have weapons. Like you can see, it's very tiny here. We can make them bigger, I guess. Okay, I'll make it bigger. Type alias. You don't like type alias? Why? Blind damage. What's wrong with type alias? I feel very insecure now. That's how I live, man. No. Okay, no. I should first fix these warnings. The import of map is redundant. Let's just put them side by side, and then we can solve the warnings because you know they're gonna build up. They're gonna be painful and annoying. 22, 25. Grid 39. I think I know what happened. I split it out into a separate module. That's why it's doing that. Okay. Clean up imports. Clean up imports. I'm on my phone. Too much work to write. Why? Well, that brings up a lot of questions. Like, why are you on your phone? But so okay, like I'll give you my explanation of why I'm using a type alias for health. I later want to change that type to something else. I already know that, right? It's not a good idea to use in there because it's signed. You know, you can have overflow, all kinds of reasons. Well, maybe I don't know. Like maybe it's a good idea. Maybe it's not a good idea. But if I'm gonna change it now to word 8, it will sort of work. Whereas I don't need to modify all the existing code. So it's like kind of a future convenience, if you like. That's why I'm using a type alias. And it also gives me the ability to read in the code that's about health. So that's why I'm using a type alias. Is it a good idea? I don't know. But as a tool, it sort of works for this particular use case because I want to probably change it in the future, maybe. And this is like a bit of a cop-out to do it right now. So, you know, it's like saying to myself, oh, you should probably change this later to something better, but we're not going to do it now. It's like a to-do. Maybe we should even do this. To-do change to something better. You know, we don't know what, but something. But I despise them. Visiting parents, and he's watching Twitch. I guess you enjoy visiting parents. Oh, okay. What were we doing? I got distracted. Right, we want to add the... Oh, we want to trigger the damage in the event cycle. So, okay, what's happening right now? We can kill people. That's good. Death is good, right? We are even part of the vegan death cult in the Discord. So we appreciate the existence of death to its fullest extent. We know it has positive impacts on global warming. So yes, death is good. But we want to have our victims be able to resist us a little bit before dying. Otherwise there's no play, no fun, no experience. Use small yuppie stream, but I'll go chill. Okay. See you later, man. Yes, so we need to update state. And this is where things are gonna be a little bit complicated. Because I don't really know how to do this, to be honest. Shoot. What? Is shoot. State towards is move. What? What? What the heck did you try to? Okay. This is not a very helpful name. What is it doing? Selected actual. Okay, selected tile is move prime. Maybe move. Should character attack. So we know if there is an enemy. And we're checking for that in should character attack. What does this function do? It is figuring out if the thing you're moving towards. What? Oh, we're applying the is attack to this. So this is just figuring out if the tile next to the select where you want to move to is in the neighbors, and if the selected tile has the player. So, dear God. And then we are also applying the boolean from this move here. So what does this function do? Is shoot. It's not is shoot. Instead, move if towards to selected. And whoa, I know why it's called issue. This is figuring out if the player is in the. We should separate this a little bit better, I think. Jesus. So this is should player move. Is should player move. Oh, to player move. To player move. So figures out if the tile we're moving towards is a neighbor of the selected tile. And verifies that the selected tile is the player. Concats the given boolean to the conditions. Concatenates the given boolean to the conditions. Okay, cool. So it's still a vague name, but whatever. It's slightly better. To is shoot, which was just nothing. To player move, yeah. Okay, and then we need to go from a move. So okay, first you figure out the move. How are you gonna move? Okay, you figured out you're gonna move. Then we want to figure out with the move. So we need to have like a combat result. Okay, see you later, Gil Christian. Thanks for watching, man. Bye. Combat result. So, make. What are we gonna make? Make is kill. Kill enemy. Kill player. Well, I guess at the moment we can only kill the enemy, or enemy lives. So, and then we're gonna jam this in. If the enemy lives, we should trash the move type. We're gonna have the move type thing, which is a thing. Move type. Oh, you already know if it's an attack. Move. Okay, so I was like, I'm just, summoning some data from. I'm not really sure how this should integrate with the rest of the update state logic. So here we have an alternative: should character move first, and I think this ignores the case where the tile is not free. Then it's not considered a move anymore. So. To player move is move. Only moves. This type is only moved if the target tile is free. Okay, next one. if the target tile contains an enemy, it'll be this move type. So you figure out the move, right? And then, well, before you want to do the move, or maybe move is not allowed. Move is only allowed to move, and I'm getting the impression that we should leave it like this. So we will just preempt the move function. We'll just keep this all the same, you know, and we will do another function, fun, that takes a move type and results into a maybe move type. Move type. And if it's an ordinary move, then, and it also gets the game state. It results in the game state as well, because we're gonna modify that. So game state gonna come out as well. And I'm gonna put it in, because, you know, maybe it should just be in state T, to be honest. Monad state. This is also monad state. Update state. What is this, man? Are you folding or something? This is crazy. I bet you're folding over this or something. Acumdyn. That's basically a state. We're gonna... This is a state, because you are getting the... Okay, look at the definition of state T. Look at the definition of state T and tell me this is not a state. State T. You get an ass and you result into an ass. You get an ass and you result into an ass. That's state, because you're modifying the state every time and you're putting it back in. That's what it is. I mean, that's what the M says, right? Like, okay, for one step you're getting the ass and then you can result into an ass. And for the next step, you're gonna get another ass and put the result in the ass. That's what it does. And that's, well, you cannot believe me that acumdyn is doing that, but it's actually doing that. Except it's reflexy style, saying it's being done over time. What I don't understand is why they don't make the API be like, okay, hey, you can be a state. But we can run state, get the state out, and some other argument. It'll be, like the function will become a lot nicer to look at it. Right. Let's do that. Monad state, game state. I don't know why people would watch this stream, but you know, if it's for MTL style magic, I'm all here. And we're just gonna pretend it's a just text a state, you know, run state. Just pretend it's this one, and then it will be done like that. Okay. Move type to move type. So move type, make walk. We can ignore the walks. Sure. Oh, we need to keep it. Pure just. And in this case, pure means to not modify the state. And then make attack. We will do the attack. I want to put this entire function into a state monad, I think. I mean, this entire right-click branch. I think I'll make a state monad out of that. And then it'll be a bit nicer to look at. Makes sense to me. Okay, we'll do that. Make walk, and then make attack. X, which is a move. And then we're just going to resolve combat between the two, right? So let's just let the player attack first, and we'll figure out how the... Well, we can do several things. We can, you know, do 2 turns, for example. We can let the player attack first, and then let the enemy attack as well in the same attack. So, you know, you as offender, you get the first attack, and then the defending party gets the next attack, or retaliation, if you will. We can do that by default, I guess. So maybe we don't want to defunctionalize this. So we have the game state, which we can modify and we can get. So from the game state, I wish to summon the grid. View the grid. No, it's not view, it's uses. Use game board. Where's the player, by the way? Do I know that? Selected game board. Oh no, we know it from the move, right? Make walk, move from, move to. Okay, since it's an attack, we know that we're gonna go from to. So move from actual in the move. Move. I'm gonna get move from move. Add maybe X. So you got game board, which is the grid, which is a map, actuals and tiles. And the tiles contains the game data. So from do to and then we can just pretend they exist and we'll apply damage with resolve combat. I don't know how to get RNG in this because this function is pure. That's a problem actually. That's a really big problem. Acumdyn. Maybe there's a monadic variant of acumdyn because this is not good. I need to look it up. Oh yeah, all of reflex probably not in Hugo. Great. So right, by the way, we're doing reflex. We're just doing some basic Haskell here, guys. Don't worry about it. Acumdyn. Is there maybe an acumdyn? There you go. Monad hold, monad fix, push m. I'm monad for doing complex push-based calculations efficiently. What is even a push-based calculation? Do the occurrence of an event. Which provide a push m action. What? Hey Contoran, how are you doing? I'm stuck now. I'm really stuck. I am inside of a acumdyn function like this, and I need to get some entropy. I need to get some randomness. However, the function is pure. It's only ABA, and I can make it a little bit less pure with push m, but I don't really know what push m is. What is a push m? Maybe I can see it in the instances. Reflex? It's a function. Oh, you should talk to Skybro. He did it, I think, to Flake based. I'm about to switch to macOS to a new Linux machine. Oh wow, that's amazing. Which one did you buy? Which one are you getting, or did you buy? I got like a Lenovo recently. Starbook. Ooh. Starbook. Oh, nice. Looks really nice. With core boot. What's core boot? Oh, that's the free free Linux BIOS. Wow, that's really. I didn't know you could actually get laptops like that. That's amazing. And I got a Lenovo. I feel bad now. You got free software. Yeah. It's too bad they come with Intels, but whatever. I mean, you got at least the free software. Right. We can get rid of the state, but we cannot get rid of randomness. And that's a problem. Maybe we should just summon some entropy in the event or something. I don't know. What would you run? Yeah, I'm doing that as well. It's amazing. Just, I mean, have you been doing Nixos? I'm excited about it. Oh yeah. Yeah, cool. Oh, because you were using OS X before, so it was like kind of problematic, I guess, to use Nix. Yeah. Yeah, but well, you know, be prepared for a little bit of pain of setting up your first graphical environment. But after that, it's like a lot of fun. A Pi with Nixels. Raspberry Pi is super high precision. I'm gonna get another drink. I'll be right back. Back in 5. Sure, I guess. Okay, I'm back. What happened? Did you guys burn the place down? Don't burn the place down. Okay, I'm back. Are you working? I'm not working with flakes. I refuse to use that stuff until it gets out of experimental. And maybe some people will explain it to me. I'm far away from sample. Not sample. You want sample. You know, in a way, like if you would call something a behavior, then random numbers are a behavior. And in a way, you can just attach it to your state. Like that, you can solve the problem, right? Initial state. Would they have like a random number? Spider hose, read phase. Yeah, I don't know. I don't even know how to get into flakes. I mean, I guess you would just start converting your next code into flakes, but the problems they're solving, I don't feel I have them right now. So no, I'm not doing it yet. Yeah, I would wish they would figure out if it's the thing they're gonna do or not. You know, the impression I got is it was still experimental. It's still an upcoming feature. That's what I mean, right? Like they're all talking about it's something from the future you're gonna use in the future. But if you're talking about it like this, I'm just thinking like, okay, I guess I could use it now, but I could also not use it now. You know, it's already working for me. Convince me, you know. Maybe there's like some critical mass in the Nix community where everyone's using flakes. Then I'll also, well, hopefully before that, I'll convert to it. But for now, no. That's some interesting. I could go side by side. Yeah, but you know, have you seen my Nix configuration? It's just like the laptop. It's quite big. And then I also have the internal one I wrote about yesterday on the blog. I wrote about how I do my services. Nothing of that is flake based. This is all just normal Nixels. So if I have to convert all of that stuff as well, it's going to be a lot of work. And I can tell you right now, I don't have the time to do that. It's too much. And you know, all of these things are also, for example, masapp or raster.click. You know, I could show it here on stream, I guess. I'm not willing to paste it online, but I'm willing to show it on stream. So this is all just generated, or reflex based. I need to convince the reflex people to switch to flakes as well. So I don't know if they're ever gonna do that. And if I'm gonna do that, then the reflex platform. I don't know. It's still around, but they should upgrade their stuff. And this would mean that I need to fix build issues in raster.click as well, which I'm just never gonna do. Because the raster.click project is pretty much abandoned at this point. So it's still online, but yeah, it's too much for me personally to do that. So there won't be a switch for me anytime soon. Might not be too complicated. It's gonna be complicated for this thing because they wrote a lot of Nix code, and this entire project needs to convert as well. But and then, you know, the 3 projects I have, but like, you know, to be fair, these like, you know, services I have here, video cut and raster.click and masapp, they are sort of copies of each other. I explained it in the blog post as well, that I just copy paste these as a way of creating a new server. So I just copy paste the entire folder and then rename it to, you know, fancy new app.org. This is my new service now. And I just start modifying stuff in here. That's my template system, and it's working really well. Like this kind of setup allows me to spin up a new service in 2 hours, 3 hours, something like that. And by new service I mean like running website with branding and everything. So I don't think anything can beat that. Yeah. But, you know, because I copy paste all the code, there's a lot of Nix code that's not flakes based, which would be problematic. And again, I'm quite disciplined about the purity of it, so maybe it's easier like that. I already pin, you know, the thing that standardizes is pinning. I already kind of make sure that the thing where I'm pulling dependencies in is always from the like global package thing. So like that, you know, all the dependencies are pulled in one place. And I think that's the other, you know, big thing they do is make sure that you pull first in all your dependencies and then you do the other stuff. So like that, the conversion will be easier, I think. But I don't know because I haven't looked into it because I don't want to. Yeah, it's my old saying, you know, people don't like change. I don't like change. Flakes as templates built in. Interesting. That is interesting. Yeah, because the way I'm doing it now, it's so ad hoc, and it doesn't, you know, 2 or 3 more of these services, and I'm gonna go crazy. Would I? I don't know. It's still working. Let's copy paste. What am I doing? Right, we're figuring this out. The randomness. I don't really know how to do it. What are you doing? Wait. Okay, this is silly. I forgot how to do this. I want to run a monadic action and then get it out. Do I need to do it in reflex? Maybe. Maybe they have like some combinator. Get ticks events. Wow, they got a lot of events. Event quit. Base transformer. Hold view. M of A. Event M of A. Well, that's it. We just do get random event. Event? We'll just sample. Then a placeholder network until the given event fires. Then replace network with events value. Hold view. Higher order switching. So we can get entropy, and then we can just run it like a normal state T, right? Like a random T. I need to have like a random transformer, I guess, and then just like use a state. Or we make randomness part of the game state. I don't know. That sounds weird. Monad random. What? Crypto Knight. That's not what I want. Come on, man. I need to make this myself. Allows one to obtain 2 distinct random number generators. What? Where's the... What? This is the one I'm using. You get me a random. You implemented monad random for IO. State T as. You already implemented it for state T. But if you have a monad random, it can be a state T. I would expect a transformer to be used to make this work, but no. No. We only provide you with IO. You would expect someone to implement something like that. Oh, well, there you go. This is what I needed. So what this allows us to do is to run ranty with an initial generator. And you are an instance of monad random, right? Yes. Okay, cool. So what do we do? What do we do? What do we do? What do we do? We don't want a, well, randoms. New STD gen. I mean, to be honest, we can just provide the natural transformation in the event, and that will be it. But oh, look at me talking fancy, man. What I mean to say is that we just provide a function that will go from rent g ma to ma, and that will be good enough. I don't want to search for Google. What do I want to search for? I want to search for STD gen. Get Freeman's. Man, I should increase those points. So this is the basis of our random. And if I get the keys, I don't know. You should ask Freeman. It's not my house. It's kind of funny. People spending those points. I'm like, okay, I should probably make something out of it, but look at that. That's like the continuation almost, right? Or state. This is state. Get STD random. It is state, isn't it? Yeah, but this thing predates state, so we cannot do it. Let's make it. So we summon. Oh, I'm not gonna like this. Well, maybe actually reflex STL probably already has IO. so that's fine. So we get a new stdgen. Okay, and then where is our function? Run t. So we need to kind of hack around this. And the other combinator, right, which was in hold view, and we need to describe the A. But in this case, we don't particularly care about random or the. Maybe we do care. Yeah, I don't know. Maybe. Yeah, we sort of do care. Let's make a function to do this for us. So make random nt, which is a monad. And you just provide a function n that will allow you to go from n. No, not n. From some stdgen based function gen to m of a. However, this is for all n. Maybe it's a monad n, but yeah, you know. That's what you do. And how do you do this? Well, you get the stdgen. No, we need to generate entropy. Well, an integer, but it's gonna be. It needs to be inside. It needs to be inside an event. So what I mean to say is, okay, consider, where is it? This type in the signature. We need to get we need to get an stdgen inside, well, an integer actually. We need to get an integer inside here, but we're only allowed to get events of type B in there, or push m things. So we need to basically comply to the reflex. So okay, keep this in mind, right? Next, to do that, we need to have some side effects. So we want to have this as well. Okay, put them together. No, yeah, no. There we go. Okay, and then another thing we need is, right, I want to have the transformer because I want to run multiple randoms as well. So that's the other puzzle piece. We can't really see it anymore like this. So that's another puzzle piece. We want to be able to do this. We want to have a transformer. So we have some initial generator and then we want to do this transformation from blah to there. We're going to slightly modify it to just be a, okay? And then we need to create that initial stdgen like this. So that's the other puzzle piece. There, and that's the global random number generator. Apply split. I don't know what split is. Oh, we need to have split, new stdgen, not get stdgen. Oh, good that we looked at the docs, right? About the inside first, fix inside later. What do you mean? We're not stuck. It's the entire point. You just fix everything in one go, man. It's already inside here, so we can just left ice cream cone it into the function like this. So if we provide this function signature, we're done. Which we can do now actually, because we are gonna get it in a lambda inner. That's the popular advice, right? If you don't know what to do, just add a lambda. And then that's already marked with stdgen, which is good. Now we need to get the initial generator, which we got from here. Okay, good. And then we got the result out, A and G. But we don't care about G, because, you know, we can't care about G. So we need to have map first. Done. That's it. Okay, next part. So we finished with this natural transformation. Now we're gonna hold the view. And to hold view, we're gonna put the make random nt in there. There we go. this will result in a dynamic with our natural transformation. So acumdyn. Okay, and then finally we need to get the events. What is the event sequence? It's a good question. Updated state. Updated state seems fine. Let's just do that. So updated state, and then we jam in our function make random empty, and that is it. No do is needed. This is inside lambda. I mean, I guess we don't need to technically. We don't need to. Can get it out like this. But I don't feel it's like improving code readability that much. But if you like it better like this, I'm all too happy to oblige. There we go. And the final part is we need to attach the dynamic to the state. Fortunately, we have a behavior which we can use. Because you're a dynamic now, you also have behavior, so we can just give you the current and attach it with describe state. What does describe state do? Oh, game state. Oh, I see. So we got the game state like that. But you're a dynamic. I'm considering if I should put the transformation inside here or not. I'm gonna say yes. Game RNG and T. Do you even show that? You don't show that. Oh god. Can you use fmap? Pure, no pure fmap. I guess so. It doesn't really matter, but whatever. Oh, that's a bit nicer. Oh, and now it's like, oh my god, you have too many. Oh, that is nicer. Wow. Jesus. That's an abomination. I want to attach you to a new type, I think. I need to put you in here. Yeah, this is my problem. Events. Acumdyn. Date state events. How do you perform events here? I kind of want to attach the... I'm doing it wrong. I'm attaching it to the state now, but it's too late. I want to make the transformation part of the argument to initial... No, not initial game state, but the update state. You're gonna get the update events, but this will be tuple with the natural transformation as well. And it'll be a bit ugly, but that's why I'm here, right? So you get this, but you also get this. Like this. I guess you cannot run a pattern match on it like this either, because you get the events and you get the NT, and then you do case of events. STDGen can be removed. STDGen. No, it cannot be removed. Well, I should check if this compiles first actually, but I don't think it can be removed because it will change the order of... it could be removed if this was flipped. Like this? Yeah, you could remove STDGen. Because no, you can remove inner. That's what I mean. If you put yeah, you can remove inner like this, but it becomes confusing with flip. So I'm like, okay, that's fine. Will include random. So what we're doing here is split the STDGen, put the function inside, you know, as a result. So this is like, you know, a result. And the idea is that we're gonna give the function, we're gonna give it for every event here. But I need to attach this acumdyn, and I should just use events. but we can hold view and acumdyn. We can just attach the current one with a tuple. But you know, I don't remember the syntax. It's the wrong way around. Okay, let's just compile, see what happens. You don't know about acumdyn. That's a fair point. Well, it's probably new to you, but you don't know that acumdyn always existed in our hearts. And we can use it to update state. Scope acumdyn. Wait, but I just import, right? Oh, it's talking about state. I didn't know it was different modules, but whatever. Rand T. Right, it's a bit obscure, but whatever. I mean, I guess the reason they made it so obscure is because it's state, and they were like, ooh, state, ooh. You can't have a state in Haskell code. It's crazy. It's like, why would you ever make useful stuff? State 137. Monad state. It's actually kind of fun implementing this. You gotta use a lot of obscure stuff, I guess. I mean, I guess why people get. I guess I understand why people would get stuck if they were using reflex SDO for game. You know, you gotta know about the MDL. It's a deep subject. It's complicated and difficult. Well, not really, but there are a couple of rules. State. Well, we can just, you know, pretend we have them on at random here, right? Now we just apply the damage. Combat. Resolve combat. Unit. Oh, it's already applied here. That's so cool. Oh, I didn't even do the thing where the right one and left one both get applied. That's so cool. I already figured everything out. And then we just need to update the from and the to, I guess. Move to, move from, so on game board in grid.hs. Tile content. So you got like tile. So we got a tile, I suppose. And then we're gonna get tile content. And then we're gonna get just. What if there's no unit? I don't know. But we're gonna find out because, well, I guess we just, you know, throw an error. No unit found. I don't know. This has to be true at this point because we already figured it out with make attack. So yeah. I mean, I guess we can gracefully ignore it if there's no unit, but yeah, maybe we should throw an error, I don't know. Throw a warning. We can fmap into it and then the error gets squashed, which is bad. I don't know. There are a lot of problems involved with this. But we can resolve the combat. I can set the units. Result of combat. Now we can just, you know, game board. Equals. I don't know if there's no unit. We can figure it out later. So I guess I'll just do pure move. I mean, I guess we don't move if there's no unit or something. I don't know. It's weird because you would expect her to be a unit because we're still resolving that function. But oh well, we gotta fix all these compilers. Mod random. I don't know about mod random state. But you know about mod random. Wait, we did anything. Or maybe I misspelled. Probably misspelled. No. I just didn't jump correct. No, I didn't. It's in combat. Oh, wait, what? Go to state. Jump up. You didn't import it. Okay. That compiled? Oh no, I didn't compile. Okay, of course. I thought I had it right on the first try, even though I did a bunch of land stuff. That's normally never the case. Yeah, of course, of course. You remove time, you remove this, you remove that. And you remove attack. Of course you remove attack. I mean, to be honest, we can just do, no, I don't want to do that. I'll just make a walk. It's fine. Just make attack move. Just make attack move. Pretty much type unit with maybe unit. Oh, what? Move to. Right, we're actually setting the unit, so, yeah, about that. We need to set tile content just TC unit. It's a bit long. It's a bit long. Well, maybe we can say this is the success of lens. You know, we're gonna lens in all that stuff. Could have type unit with actual type unit. I'm saying second. What is result? Unit. We don't know if there is a result because you're maybe. Yeah, maybe not. I don't know. Take a break. Yeah, I'll take a small break. We should look at the return time for result. Yeah, continue. Okay, of course. Mod random, but also we F mapped into the maybes. We shouldn't have F mapped. We should just squash the maybes first. Oh, this from maybe error. From you unit is equal to from maybe unexpected. Just do it like this. I don't wanna, like, okay, I don't really know how to solve it, because logically we shouldn't, like, you know, a type should just be correct, but we structured it in such a way that we can't know at this point, which is unfortunate, you know. This is a to-do. Figure out how to structure that this isn't necessary. Because I want to just make it work. So like this, we at least get proper debugging. This maybe. And the second thing this does is it pins down the type because it got confused about type. So we wanna fix that as well. So rather than from no unit. And if we crash on this, we know where it's coming from with the message. That's the other point. So we can kind of ignore the problem while we deal with the random problem first, because the random problem is actually causing us to not. Of course, you don't know what that may be. The random problem is causing us to not be able to continue, which is bad. And it's a tuple. I don't like that, but what are you gonna do? Left unit, right unit. Okay. Tile, but maybe tile. Yeah, so we can squash another maybe, that's completely fine. Wait, is this the right spot? I don't know. Guess so. Use game mode from. And the problems keep on stacking. What if you can't find a tile? I feel we're doing it wrong in the following way. Like, we are doing this computation after doing another computation, but we already looked up all these variables at one point. Now we're looking again, and we have to do all this checking again. So logically, I would say the way to solve this isn't to do the computation here, but to push it like as a callback down in the stack. You know, rather than defunctionalize with the make attack, we solve the attacking problem within the move function. But I just want to make it work first and then figure that out. Okay, so use, do you have the we're using use. One that's what I use is alive. You can also have getter use, which always must exist, but we don't know if it exists. So we want to have a default, or maybe returning, maybe I use, though it's interesting. I don't know if it exists. So we have like, you know, so this is the analog of view. We want to have the analog of preview. I don't know what it is, or state monad. This will work on monad state. This is actually like the Haskell problem. They kind of make this the same name, but it should be the same name because this is working in a monad reader. And you know, a proper language would be able to unify these two because the reader is technically, you know, every state is also a reader. So why can't you do that, Haskell? Why can't you do this? But it cannot, so that's why there are two names. Shitty Haskell can't even do this thing. I don't know which language can, but you know, you should be able to. And because Haskell is so inept that it cannot even do this one simple thing, I don't know the function name for preview, the analog of preview, because preview allows us to get things we're not sure about. But maybe if we scroll down a bit, we get the one in state, pre-use. That's it. Obviously, if you have use, you also have pre-use. This one allows you to check for things that may or may not exist. So we have another maybe, and that will resolve the monoid constraint here, because it's saying like, okay, I cannot guarantee you a return, and because you're not a monoid, therefore you don't have a empty value, which is basically the default value in Haskell. I sometimes don't know what to return. What should I do? That's the error here. That's this error. And we say to him, no, it's fine, just return a maybe. It's fine that you don't know, you know, you tried your best. And we'll just prefix this with an M. And we're gonna use our one trick pony to make a from, which is a tile. And from is from maybe. Error. Could not find style where expected. And this is my workaround because we didn't structure this properly. But we're gonna structure it properly later, probably, maybe. We may not. This will just work. But, you know, we could. Two maybe. You're such a joker. Find from tile. And I'm carefully making sure these strings are slightly different to each other to ensure that we indeed know where the error came from. And I don't care as much about the to-do statement, because you know it's a to-do statement. Who cares? Done. Okay, moving on. We don't know about M. So this is like another Haskell issue. Once you start playing with for all, you need to be for all. You cannot just pretend you know for all without saying M as well. And A. We don't need a new type. And I misspelled again because I am, you know. Well, you know, you could say it's capital case because it's an abbreviation for natural transformation. Good imagine. Match type rand. Right, I just did something here, by the way, so I wouldn't expect that to compile. But, you know, good try. Sometimes you get lucky, sometimes. Okay, we need to know how to do this thing. Behavior AB to event TE. Actually, that looks what I wanted to do, but I think I flipped it because you are the behavior NT, and then in the actual type we said of update state. Well, the other thing is that this doesn't have an NT, so we should just summon an NT as well. That's no problem. Oh, I guess we can do that. We can do the initial and then just do pure here. It's the same. So my idea here is that we make the initial NT, which will be set in the acumdyn as well. You know, this is our time mechanism. And every time we get an event, this function will run again. Make random NT to create a new seed. So we can use that for entropy. And we can make it available in our update state function. Because you love entropy. And like that. Figured everything out. Okay, cool. Initial state, current acumdyn. Could I match expected type game state with actual type? Update event. Oh, it's the state, right? We don't need to give that. I'm confused. Oh, look at me. Well, that makes this a little bit easier. Can delete all that stuff as well. Nice. Okay. Another deduce functor n arising of the use of fmap. Well, that's a good point. I guess we can pretend you're a functor at least. Not deduce functor n. Maybe we use allow ambiguous types. I think I need an existential. I think I need a new type. Oh no. It wasn't going so well. I'm not allowed to have map. And I cannot deduce the n. And it doesn't work. Because we're putting it into the box and it cannot figure out. Okay, we'll put it in a new type. You can be existential, man. I need to wait. Can I just compose this? I bet I can. I can just compose it. I'll just use the good degree instance instead of functor, which is implied by the function. It's not a function, it says. Oh. What if I go deeper? Double function, it says. Okay. You win this one. We need to have functor. Fix up the type. Okay. We can always pretend that imperative types actually exist. But I've tried this so often, you know, and it never exists. But it should exist, right? This is just another basic feature you would expect a Haskell to have. But apparently they're just too, I don't know what they are. But imperative type polymorphism not supported again, every time. So what I'm doing now is I'm making a new type to hold the existential, because we need to ensure that for all n there is a functor instance for the natural transformation. Otherwise we're not allowed to do this. And you're gonna ask yourself, what's the difference between these two things? Well, the difference is the new type. Still wanna have A though. So the thing about existential is that they are really annoying. They are really annoying. And if you can avoid them, you should probably avoid them. But in this case, we cannot really avoid them without restructuring everything. You know, technically we can just give an STD gen and figure all this stuff inside the call site. But no, that's thinking like a weakling. We don't need that stuff. We can use existentials because we are cool like that. Okay. So then the other thing I want to have is like an rand nt. Okay, cool. To expose the function within a bracket. I guess we can use coerce, but I don't think we can coerce actually because it's existential. You know, not allowed to do anything with an existential. So why would you even make one? But now you are a functor as proof. Because if you're not a functor, this you cannot put something in here if you're not a functor. Therefore, you are a functor by definition. Okay. Rank and type, yeah, of course, rank and types, of course. And that's the other thing. We need to push you down the stack because now combat state needs to know about you as well, because you're no longer, you know, type, just this thing. And yeah, I mean, I guess it looks nicer, you know, it looks like a real data type, even though it's just a function. But I'm not even using it. Not even using it. But there may be more trouble later on. Did you intend to use rank and types? Yes, of course I intend to use rank and types. My life is rank and types. You may ask yourself, what is a rank and type? Well, that's a good question. It's a really good question. You should read a book about it. There is actually a book about it called Thinking with Types, and they explain it. And I think it's a one-cap chapter, rank and types. It's about like, you can flip the way you think about polymorphic type resolution. So normally we do that at the call site, but you can also do this at the, I think it's called dispatch site. So rather than the call site where you use the function, it's where you define the function. And it's like flipping the logic of polymorphic resolution like that. So that's what a rank type is. And that's like a really poor explanation, by the way. That's why he has a chapter for it. I recommend Sandy McGuire's work, Thinking with Types. It's great. There are two. No, you don't understand. I forgot to save. Right, now this no longer works because you need to be like that, you need to be like that, and you are a function. Yeah, this works. Did you see that compile? It's compiling now. Did you see that? It's compiling now. Oh my god, so good. Oh my god, you spent like 1 hour dealing with compile errors. It's crazy. We haven't even used it. That's the other crazy part. We got the natural transformation though. Let's use it. So we got fun as well. How do I use this? How do I use this? So we need to not do this, I think. Because what this is doing, it's just jamming everything immediately in the result. So moved state, we call this moved state. Move plan. And before it was like this, right? Move state and the move plan done. Result. I guess like moved state is the result. I'm just giving better names to these things because, you know, I got so confused by the crap I wrote before. It's also compiled. Okay. We got the progress. Where is our fun? You may wonder where these awful names come from. They come from this, where I'm just figuring out the types and not really looking at the names. So we just call this apply attack. Because I don't know. And it doesn't even do anything to the move, it just updates the state. So, you know, attacked. So now we got the NT. We want to run the NT first. Apply attack, move plan. Random. Resolve RNG. Resolve RNG. Okay. I just realized that resolve RNG as a function cannot be reused the way I wanted to, because I didn't expose I didn't expose the seed to the function. So and I didn't expose the seed to the function because I wanted to make it a little bit neater, right? But now I cannot reuse the function at all. I can just only use it for this situation. I guess that's fine, but we went through all this effort to make it a functor here. We could do it here. And now I realize that it's not reusable at all because like the next time you apply it, it will start with the exact same seed. I mean, it will still get updated here because we have the global old view thing blah here. Let's get updated with events, but yeah, we spent basically what I'm trying to say is that this is a complete waste of time and we shouldn't have done this in the first place, but I did it anyway. And the reason we shouldn't have done this is because I modified this type signature, or this type signature to be exact, NA. It shouldn't have been NA, it should have been yesterday seed NA, but I didn't, so that's my fault. Let's just continue. We're making a lot of mistakes, you know, but we're learning from them, and slowly but surely our game is doing something more and more. That's the idea. We almost, and like the we are able now to do random stuff in the game, which is like a massive progress. And the next thing we want to do is we want to have a state monad for our game state, which will make it a bit nicer to use the so how do you run state T? Yeah, that's it. I put in the and this is basically the same as the random thing, but in this case we're not gonna delete the s because we're interested in the s. So I need to give it an s. So first we'll do the thing. Oh, we just flip it. It's kind of annoying. But state goes in here. And then you put in the state T, blah blah blah. Out comes the M. Oh no, we don't want to run state T, we want to run state. We can just use identity at the base. Because we're pure. This is still a pure function, by the way, even though we have state. It's a pure function. Yes. New state. I mean, to be honest, it doesn't even have to return anything. I can just update the game state, right? Yeah, I'm fine with that. Makes it a bit easier to, you know, just do pure. There you go. Then we can eval state instead of run state. Or I mean access state. Completely different thing. New state, there you go. Holy shit. I mean, it's kind of crazy if this works. Because, you know, we made a pure function into a monadic function with randomness, with a reflex. But I don't see why it shouldn't work. I've never seen something like this. Resolve RNG. Okay, let's see. Damage type M. Fly attack. You're pretending you are a attack. Where's apply attack? Move plan. Now we resolve the RNG. Oh, I need to call the thing nRandT. Right. Because we made it very complicated. Right, if there's no move plan, then we don't have to do this. So from maybe do nothing. State. Plan. Match type A with unit. Can we just say you're like, you know, unit? Oh, that worked. Okay, cool. What? So it should work now? I don't know. Oh, you even know it works. We're not even rendering the we're not even rendering the we're not even rendering the health bars. We are just making damage. Okay. Alright, I need to actually not put it in here, but in the package.yaml, I think, yeah. I just gave up on Kabul at this point. It's like, nope. Just enable everything, I don't care. Make HPack, okay. It's just too annoying to deal with Kabul. I mean, I guess, like, you know, at work we do it directly with Kabul, but you know, they already included everything anyway. It's crazy, you know. You just include kitchen sink, this massive monolithic project. I guess that solves the problem as well. You don't have to add anything ever, because it's already included. And again, you know, I added myself like 10 things, so I'm part of the problem. No, I just casually add lens. Then every dependency of lens and okay. Oh, my unit is different player. my health is minus crazy amount. It's working. It's still fast as well. It's crazy. Oh, my health is now like this. I don't know why it's so big, but there you have it. I think it's completely unbounded integer. Just picking random integer, applying that, you know. Now it's like this. Jesus. Well, there you go. We're not really adding, subtracting. Maybe it's like complete overflow. Who knows? But this is working. It's calculating the HP, and we're updating state, and we haven't actually, you know, rendered the health bar or bound this to proper values, but we'll do that next week. I think we did the hard part here, because we now can run random stuff in the game, and we can, you know, use state monad instead of this crap to update the game state, which is a bit more convenient. I'm kind of inclined to push this state monad out of this over the entire thing, maybe even out of here, because then your bit like updates will be more consistent. But that will be next time. See you all later. I'm gonna hang. Bye.